Number 11, which of the following numbers is not a solution of the inequality 3x minus 5 is greater than or equal to 4x minus 3? So let's just solve that, right? And see what kinds of x values are possible for this to be met, right? So let me subtract 3x on both sides. That'll leave me negative 5 is greater than or equal to x minus 3. Add 3 on both sides. Negative 2 is greater than or equal to x. So what do we know? X has to be less than 2 or less than negative 2 or equal to negative 2, right? So it could be, well, for example, it could be like negative 10 because that's less than negative 2. It could be like negative 9 all the way till negative 2 it could be up to. But anything bigger than negative 2 it cannot be, right? Negative 2 works, negative 3 works, negative 5 works. The only choice that doesn't work is A, negative 1. Very simple question. Number 12. Based on the histogram above of the following, which is closest to the average arithmetic mean number of seeds per apple? So what's the average number of seeds per apple? And we have the diagram here. Now, a lot of people don't really know how to read this diagram, so I'm going to show you guys how to read this one. So obviously, this label, the vertical axis label, is number of apples, and the horizontal label is number of seeds, right? So let's take an example of this column over here, right? So for that one, the number of seeds is 3, right? So 3 seeds here. And this for over here, the number of apples is 2. What does that mean? For that one, there are 2 apples that have 3 seeds each. Does that make sense? So that's how you read this diagram here. So a lot of people get confused when it comes to this diagram. That's all that means. That column means there are 2 apples that have 3 seeds. Does that make sense? So they are asking us to find the average, right? How do we find the average, right? Well, average, as we hopefully are familiar with, is sum divided by number of things, right? Number of things, number of people, whatever number of what you're dealing with in the question. In this case, the number of apples that we will be dealing with, right? So we want the average number of seeds. So the sum here, for our case, would be seeds here. Well, to be more specific, to be more specific, number of seeds here. And here would be number of apples, right? So let's try to count the number of seeds and number of apples, like overall, right? So how many apples do we have, first of all? Let's count that. We've got 2 apples here. So let's write that. 2 apples, 4 apples, 1 apple, 2 apples, and 3 apples. So we've got a total of 5, 6, 10, 12 apples. So we've got 12 apples. And let's count the seeds, right? The total number of seeds. Let's look at this column. There are 2 apples with 3 seeds. That means there should be a total of 6 seeds, right? 2 times 3, right? Because there are 2 apples, each of them with 3 seeds, right? Here, there are 4 apples with 5 seeds in each. So that will be 5 times 4, 20 seeds here. There is 1 apple with 6 seeds, so a total of 6 seeds here. There are 2 apples with 7 seeds total, so there are 14 seeds total here. And there are 3 apples with 9 seeds in it each, so there are 27 seeds total in here. So let's count the number of all the seeds, right? That's 20, 40, 67, 73, right? So we've got total of 73 seats. And then we've got 12 apples. And that will give me the average number of seeds per apple, right? The average number of seeds per apple, right? You guys see how the units work out nicely too? Seeds per apple, right? So, we are asked to find the closest number. Well, let's take a look. Well, once again, you are allowed to use your calculator on this section, so please go ahead and use a calculator, but for the sake of my mental math, well, I know 72 divided by 12 is exactly 6, which means 73 divided by 12 should be pretty darn close to something like 6, which leads to answer choice C. Number 13. A group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. Which of the following categories accounts for approximately 19% of the survey respondents? Okay, so we want 19% of the survey respondents, right? So survey respondents were how many? Total of them. Well, it says total. So very total over here was 310, right? 310 students, of which we want roughly about 19% of, so 19% of the 310 students, right? So how many is that? That's roughly about 59 people, right? How did I get that? 310 times 0.19, right? So that's roughly about 59 people. So in the table, we're looking for a number that is pretty close to 59 people, because 59 is 19% of 310 total survey respondents. So let's go through it and look for 59 people. Females taking geometry 53, not quite. Females taking algebra 2, 62, not quite. Males taking geometry, oh, 59, I like that. Males taking algebra 1, male algebra 1, 44, not quite, so probably my answer choice, C, right? The reason I did this step first, guys, the reason I took 19% of the 310 students first and then jumped to the answer choices is because I did not want to check all of the four choices one by one. Because imagine this. Imagine I started in A, right? Females taking geometry. I'll be like, okay, female geometry, there's 53. And then I'll be like, okay, 53 divided by 310. And what percent is that, right? And then I'll go B, females taking algebra 2, which is 62. And I'll be like, 62 divided by 310. And what percent is that? Imagine doing this for like, 3 different times, 4 different times. I just didn't want to do that. And that's why I just went ahead and took the 19% of the 310, the total survey respondents first, and then use this number to actually look for wherever the closest number to 59 is at, because that would be much easier and much less time consuming in order to do this problem. Number 14, the table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. I see that over there, 24 inches. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? Okay, so let's think about that. Well, first of all, imagine if you were to try to find all the mean, median, and range for that box of data there. This is a time test, right? You're only given a certain amount of time to do the whole test, and that's going to take so much of your time. So let's think about that logically, right? So let's do something easy, which will be the range. Range is pretty simple. It goes from 8 all the way to 24. So that's range, right? To be more specific, mathematically, range is 24 minus 8, so 16 would be your range, right? Well, but you don't really have to know this part. Range, just, logically speaking, it's from 8 to 24. That's the range, right? Let's think about mean. Well, it goes from like 8 to like 16-ish. So, get rid of the 24, right? The range should be about, not the range. The mean should be about right in the middle, which should be like 12-inch, 13-inch-ish, right? And the median obviously is the middle number, which is about also 12 and 13, right? So imagine I remove the 24. First of all, is the median going to change that much? Probably not, right? Because median is literally just the middle guy, right? So how many are there? 21, right? So the 11th one should be the middle one. So 7, 8, 9, 10, 11. So 12 is the median. Imagine I get rid of this guy. Now the median will be the 10th guy and the 11th guy and the average of that. 10th guy is 12. 11th guy is also 12. So once again, median is still 12. Median doesn't change, right? Or even if it did change, right? I didn't actually have to count all that. Even if it did change, it wouldn't change that much because I'm only removing one piece of datum from the set. So the median is not going to change that much. So we can get rid of the median. Mean is the average, right? And how do we get average? Once again, average is the sum divided by number of things, right? In this case, the 21 fish that we have here, right? So imagine I add them all up, which I don't know, just guesstimate like 10 in each. There are 21 of them, so like 210, and divide by 21 fish, right? Imagine I get rid of this guy, 24, which is going to give me about 186 divided by 21. It's probably not going to be that much of a difference. This is 10, and that's about like 9-ish. 10 and 9, it changed only about like 1, right? Once again, I didn't really have to do this. Just logically speaking, I'm only removing one fish out of 21 fish that I took the average of. The average really shouldn't change that much. But you think about range, it's a little bit of a different story because think about it. It was from 8 to 24. Let me remove the 24 here, right? Then now, we only have 8 to 16 at most. My new range becomes from 8 to 16. Mathematically speaking, 16 minus 8, 8. You see how there's very big difference between the old range and the new range, right? Why? Because range is literally how small I can go all the way to how big I can go, right? But then I just removed the biggest number out of the list, which means the range will shrink by a significant amount. It was from 8 to 24 originally, but now I can only go from 8 to 16. So what's going to change the most? Probably the range, right? The logical part here in this question is that the median and the mean really won't change by that much just because you're removing just one piece of data out of your list, right? Especially when 24 is not even that much bigger than 16. If the 24 was not 24 and if it was like 240, yes, that will make a huge difference in terms of the mean, because now whatever I add on top will be much more than before. But 24 is not that significantly bigger than 16. So really the range will change the most in this case. Number 15, the total cost of renting a boat by the hour. We have this graph. The graph above displays the total cost C in dollars of renting a boat for H hours. What does C-intercept represent in the graph? All right, so let's take a look. C is on the y-axis, and it should be H here, right? And h is on the x-axis, right? So c-intercept would be the point where this graph crosses the c-axis, aka right this point over here, right? Where the value is 0, 5. 0 for the h and 5 for the c. Okay, so let's think about what that means, right? What does that mean? H is 0, aka the hours is 0, aka I borrowed it, but I haven't used the boat just yet, right? C is the total cost in dollars. So think about it. For borrowing it for 0 hours, I need to pay $5. What do you think that means? So imagine, I mean, you guys go skiing, you guys go snowboarding and all that, right? When you, or even like, I don't know, you guys go-kart or whatever, right? You guys pay, right? And then you get to ride whatever you're there for. But this is saying, hey, riding 0 hours, you still have to pay $5. What does that mean? Just logically speaking. Probably the rental cost, right? Probably the cost just to get the boat to rent it out, right? Because, I mean, I haven't even used it, but still I have to pay $5. That probably is the cost that I have to pay to rent the equipment, right? So let's go through the choices, and whatever fits what we just said should be my answer, right? A, the initial cost of renting the boat. That sounds pretty good, right? That sounds very close to what we just said, right? B, the total number of hours rented. It says hours is H, right? It's got nothing to do with C-intercept, right? The total number of hours, once again, we're not talking about hours, right? D, in fact, B and C sound the same. The total number of hours rented, the total number of hours the boat is rented. I mean, what else is being rented, right? D, the increase in cost to rent the boat for each additional hour. Once again, we just said the $5 is for not even using it just yet, because it's probably the initial cost of renting the boat. Number 16, continuing with the same question. Which of the following represents the relationship between H and C? All right, so take a look at your answer choices. 3H, C is equal to 3H. C is equal to 3/4 H plus 5. C is equal to 3H plus 5. H is equal to 3C. We've seen something like that before. We're not too sure. We're kind of confused. Let's look at the graph. What does that graph look like? A line, right? A linear equation. You guys all remember the linear equation? Y is equal to mx plus b for drawing a line, right? Straight line. Well, that is a straight line, right? So it should look something like this, except we don't have the x and y here, but instead we got h and c. We have c in the place of y, so let's replace that y with c. And we have h in the place of x, so let's replace that x with h. So it should look something like this. You guys all see that? C is equal to slope, and instead of x, we have h, and then the y-intercept, right? We already have c is equal to something. We can go ahead and get rid of d right off the bat, because that's h is equal to something, and we're not going to have that, right? We're going to have c is equal to something. Okay? Now, we need to find out the m and the b. M is the slope, right? And b is the y-intercept, right? Well, to find out the slope is rise over run. And that kind of looks a little bit difficult, so I'm going to go with y-intercept first, because that's easy to tell. It's just the point where it crosses the y-axis. In this case, we're going to have to call it c-intercept, right? Because there's no y here. There's only c in the place of y. So c-intercept, right? C-intercept, which is right over here, where it is 5 for the c, right? So we know it's going to be plus 5. What can I get rid of? A. I can get rid of that guy. So now I'm stuck between b and c. Take a look, guys. The slope for one of them is 3/4, which is not even 1. And the other one has a slope of 3. That's a significant difference, right? So for b, it better be like some flat line like that, because 3/4 is not that big of a slope. And for c, it better be pretty steep line like that, right? So I just need to tell which one is closer to. Just by looking at it, it looks like it's closer to C, but let's just make sure, right? So let's take a look. From this point to this point, I'm just going to grab any random point and just do a sample, but I'm just going to pick the first and second point because it's the easiest, right? Smallest numbers. So from here to here, that's a run of 1. And from here to here, that's a rise that went from 5 to 8, so rise is 3. So rise over run, right? The rise was 3, run was 1, so roughly about slope of 3. So as we guessed, our answer is choice C. You guys realize when you were between B and C, you really didn't have to do much math because one is very obviously flat line and the other one is very obviously steep line. Number 17, the complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? All right, so what is f of x? It says y is equal to f of x, right? So f of x is just nothing more than y, right? So what is technically this question asking then? So for what value of x is the value of y, right? Y at its minimum. So let's look for where the y is at its minimum, the y value, right? That's obviously the maximum for the y because it's up at the highest out of the entire graphs. So we're probably looking at here, this point, right, where the y is at its minimum, aka the f of x is at its minimum. What's the point? What are the coordinates there? The x is -3 and the y is -2, right? And that's where the y is minimum, aka the f of x is minimum. What's the question asking? For what value of x is the value of y at its minimum? Well, it's over there. What's the value of x there? -3. Your answer is B. Please do not be intimidated just because you haven't seen a graph that looks like this before. It's actually super simple, and trust me, SAT will never ever expect you to actually know and understand fully a graph that looks something like this. It just will not be the case for you. Number 18, y is less than -x plus a and y is greater than x plus b. In the xy plane, if 0, 0 is a solution to the system of inequalities above, which of the following relationships between a and b must be true? Now, be careful, guys. It says must be true, right? So whatever the case is, if we plug in anything for a and b, it better meet under every single condition, right? Because it says must, right? So let's think about it. It says 0, 0 is a solution. Let's think about that 0, 0. What is that? The only thing that we know about the numbers inside the parentheses is xy value, right? So 0, 0 means x and y. So x is 0, y is 0. And what do they say about it? 0, 0 is a solution to the system of inequalities above. So this system of inequalities, 0, 0 is a solution to both of those. What does that mean? If I plug in 0 for x and 0 for y into both of these inequalities, it better work every single time. So let's go ahead and plug those 0, 0s into both of the inequalities. Let me start with the top one. So we have y is less than -x plus a, and I'm going to plug in zeros, right? So y, 0 for y and 0 for x, right? So what does this come down to? Okay, well, 0 is just 0. 0 is also just 0. So 0 is less than a. We come to that. Let's try the other one. Y is greater than x plus b. Once again, I'm going to plug in 0 for both of them. So 0 is greater than 0 plus b, aka 0 is greater than b. Now, what can we conclude about these? I mean, we still don't know what a or b is, but we do know a is definitely greater than 0, aka what does that mean? A must be positive, right? Because it's greater than 0, right? But b, on the other hand, is less than 0, aka B probably has to be negative. So that's the only conclusion we can draw by using this 0, 0 as a solution, right? Let's go ahead and jump onto choices and see if we can answer anything based on just this, right? So we know A is positive, B is negative. A is greater than B. Is that true under every single circumstance? Yes, right? Because we just said A is positive and B is negative, which means A has to be greater than B under every single circumstance. So our answer choice is A. Let me just go ahead and review the rest of the choices in case you guys are curious about your wrong answer if you got this wrong. B says B is greater than A. Negative cannot be greater than positive, right? So that's off. Absolute value of A is greater than absolute value of B. Now, that could be true because think about it. A could be like, say, positive 4, and B could be, let's say, negative 2. So absolute value of positive 4 would be just 4, and absolute value of negative 2 would be just 2. So 4 is greater than 2. But think about the other way around, though. What if A was positive 2 and B was negative 4? Now what does that become then? Absolute value of positive 2 is just 2. Absolute value of negative 4 is just 4. And 2 is not greater than 4. So this can be true. This choice C can be true, but not must be true under every single circumstance. That's why we get rid of this guy. And D says A is equal to negative of B, which once again doesn't necessarily have to be true. So we can get rid of that. Must be true. It has to be true under every single circumstance, which is choice A over here. Number 19. A food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day? All right, so as you guys can see, this is a very simple system of equations problem. And how do I figure that out? As soon as I read the problem, I figured out that I'm probably going to be doing systems of equations. And how did I know that? Well, let's read the problem once again. A food truck was sold for $6.50 each. So salads were sold $6.50 each and drinks were sold $2 each. Already there, we've got two different things going on, right? We have salads going on and we got drinks going on, right? So we already have two different, I'm just going to say things, okay? Two different things, right? So we already got two different things going on. And then I read again, and it goes, the food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. So I'm given, once again, two different numbers. So I've got two different things going on, and I've got two different numbers, and also two different numbers here. Just based on that, I know systems of equations that deal with x and y, and I've got two equations to work with, probably going to be very similar for this type of problem here, right? So let's just kind of organize everything here. Salads were sold for $6.50 each, and then drinks were sold for $2 each, and then total of 209 salads and drinks. So I can say salad plus drink was 209, right? Saying that S is the number of salads sold and D is the number of drinks sold. And then I also got this $836.50 for the total. Now, how would I write that? Well, I know salads were sold for $6.50 each. So if I want to calculate the profit made from selling salads, I can probably say $6.50 each times salad, right? Now, how did I get that? Watch this. It says $650 each per salad, right? And then if I multiply this by salad, which is what I did over here, right? You see how I multiply the $6.50 by S, number of salads? See what happens. The salads cancel, and then it only gives you the dollar sign as your unit, right? And that's how I know for sure that this is going to be in terms of dollars, and that's how I got this 650 times S, right? And same goes with this. $2 each drink for D many drinks, I can say 2 times D. And the total profit generated from the salad and so the salads and the drinks together was $836.50. So these are the two equations I can work with, right? So let me just write it nicely here. S plus D is 209, and then 650S plus 2D is equal to 836.50. All right, once again, I've got two different equations. I've got two different variables, probably systems of equations, right? So let's just go ahead and solve this. Now, when I'm solving this, I want to make sure I'm canceling the right variable. What do I mean by that? What am I asked in this question to figure out? How many salads were sold, right? So we are solving for salads, not the drinks, right? So if I'm going to cancel out one or the other variable, I probably want to cancel out this guy D over here because I'm trying to figure out how many salads were sold. So if I can get S is equal to something at the end of the day, I can just go ahead and circle my answer. But if I found what D was, I would have to plug it back in here and then solve for S again. That's a two-step way. So I'm going to go ahead and cancel out the D, okay? So for the top one, I'm going to multiply the top by -2. Once again, why am I doing that? Because I want to cancel out the D's, right? So what does this lead me to? -2S minus 2D is equal to -418. And then I've got 6.50S plus 2D is equal to 836.50. Go ahead and cancel these guys here. I get 450S is equal to, what is that? 418.50. And when you divide by 4.50 on both sides, you should get something very close to like 90 something. What is it? 90, let's see. Yeah, it's probably 93. So my answer choice is choice B, 93. Now, you guys might be wondering how I just got that 93 and how I was kind of able to guess that it was going to be something close to 90 something. Because, well, 418.50 divided by 4.50, right? So I hate to deal with decimals, so what I like to do most of the times is just move out the decimals for both of them to the right, and then this thing just becomes 41850 over 450. So I can kind of guess that it's going to be like less than 100, right? For sure less than 100, because what this would give you is 100, right? This will give you 100. But this is less than that because the numerator is a little bit less than that. So I know it's going to be less than 100, but still like, you know, somewhere close enough to 100, but not really 100. I'm looking at this 105 is definitely out of my budget. 77 is just too low. And I'm between 93 and 99, and I can see that this is not like very close to 100. 99 is a very close number to 100. That's why I just kind of guessed that it's going to be around 93.